Okay, so we've seen how we produce these global climate models. What do they actually predict as the effects of global warming? So luckily for me producing these things, the Intergovernmental Panel on Climate Change, which is a United Nations committee bringing together all the climate experts from around the world, has recently released its AR6 assessment, which is the best attempt of climate scientists to synthesize all the information and come up with fairly conservative and well-considered assessments of what's going on. So what I'm showing you here is primarily from this report, which you can check out for yourself. Now this shows the climate sensitivity estimates from the IPCC. They split it into two. This is a transient climate response. That's how it responds quickly to the climate. But if it gets hot, there's lots of CO2 for a long time, then you start getting other effects. For example, the oceans will heat all the way through rather than just the surface levels. You might start getting carbon boiling off from permafrost. And so long-term effects can be more severe than short-term effects. So short-term, you've got the process understanding, which is basically what the models say. And that's giving a climate sensitivity of around 2. Instrumental record, that's looking at the temperature data for the last 50 or 60 years, also agrees with about that. So the different predictions are generally it's about 2, so doubling CO2 will raise the temperature by about 2 degrees. Longer term, it's both more uncertain and worse. So the modelling says it's probably about 3, but could be as high as 8. Instrumental record says about 3. For this you can look at the paleoclimate data, and that's very uncertain but gives a very wide range. And so overall it could be as low as 2 but could be as high as 6 and probably somewhere between 3 and 4 degrees long term. So the transient response would be if we doubled CO2 and then somehow managed to claw it back fairly quickly, was if we doubled CO2 and it stayed the case. And of course CO2 that we release will generally stay in the atmosphere for centuries, then we're looking at potentially 3 or 4 degree rises if the CO2 doubles. What's causing this? Well, here they've broken down what's causing the temperature in 2019 relative to pre-industrial 1750. And so you get positive effects. This is carbon dioxide is the biggest one. Then the other greenhouse gases, CH4, N2O and halogens. Ozone has an effect. Stratospheric water vapor, not much of an effect. This is albedo. You've got dark particles like soot being deposited on snow and ice that makes things hotter, but you've also got changes in land use that make it cooler. Contrails and aviation-induced cirrus, a small positive effect. And the big negative one is the aerosols, all that pollution around the world which is keeping us cold. If it wasn't for that, the temperature rise would have been much larger. So factoring them all in, it says we're about 1.2 degrees warmer than pre-industrial, which is more or less what you'd expect from the data. And looking forward, here are projections going into the future. These projections were done a few years ago, so they're in some ways already out of date. So this is going to depend on what we as humans do about our global greenhouse emissions. So they've got the high models and the low models. This is where basically we don't do very much, and the low is where we act very seriously. And there's an uncertainty, which is for around the low and high models, which represents a lack of knowledge about how climate systems work. And you can see that for a high model we blow past 2 degrees by 2030 or 2040, and then we're heading up to about 4 degrees by 2100 AD, which children being born now will still be alive then. If we do a lot, then it maybe plateaus at below 2 degrees and then starts turning down. So everything depends on what we as humans do. Now that's the global average temperature change. This will give different results in different regions. So this is the projections of the GC global climate models. And if we have an overall 1 degree warming, which is where we're about at the moment, you can see that it's going to be a bigger effect in a few regions in the Arctic, less over the oceans, and there's actually a patch in the North Atlantic where it might get a bit cooler. This is the observed change, this is the simulated change, which look pretty good. By the time you go up to 1.5 degrees, you're definitely looking at a major change in the Arctic, but less over the southern oceans, for example. And you can see the patterns as you get to 2 degrees and 4 degrees globally, that actually for 4 degrees globally, you're getting more like 7 degrees in the Arctic. Out back Western Australia is relatively bad, whereas the oceans aren't so bad, though still fairly bad. So that's the best guess of what the temperatures will do. What would it take to address this? Well, here is what we would need to try and keep global warming to 1.5 degrees or 2 degrees. Given we're already nearly at 1.5 degrees, and may well actually pass, may even pass it this year, I'm filming this in 2023, it's going to be very hard to get it down to that. But that would basically requires this is over the years and how much CO2 we emit. The red line is what we'll be emitting if all the various governments in the world stick to their current policies. Of course, some governments will say this is their policy and not actually enforce it, so it could be worse than that, and the uncertainty is quite large. But that leads to a warming of about 3.2 degrees by 2100 AD. To get it down to 1.5, you need to do drastic cuts immediately and bring it down close to 0 by 2060. If you want to limit it to 2 degrees, then you need to cut not quite so dramatically, but still you need a lot of cuts very soon. You need to have cut it by 50% by 2040 around the world. And bear in mind there are rapidly growing economies around the world where naturally their global warming and gas emission was going to go up unless you do something fairly drastic. This is what countries have pledged to achieve by 2030, which is not enough to achieve 1.5 or 2 degrees, but still better than what's currently implemented. If you actually believe the countries will actually meet this. Another way to look at this is carbon budgets. So this is telling you how much CO2 has been emitted historically up to the present, and this is how much we've got left that we can emit if we're going to keep the temperature rise to within 1.5 degrees with a 50% chance. If we want to keep it within 2 degrees, this is our estimate, though there's some uncertainty in that. So you can see we've already used up as humanity most of the carbon budget, or the carbon that we have available if we're not going to heat up by more than 1.5 or 2 degrees. There's only a little bit left of oil or coal or gas to burn. If we keep burning things at the current rate, then this is where we'll be at by 2030, so about 1.5 degrees. So it seems to be a little bit worse than that. If we keep all our current fossil fuel power plants and other infrastructure until they come to the end of their current lives, just burning at the current rate, we'll go a little bit over 1.5%. If we do have all our existing plants burning at the current rate, plus the ones that are currently planned, then we're going to be hitting about 2 degrees. And that's not doing anything new that hasn't been planned or isn't existing. So if you want to stay below 1.5 degrees, it's not enough just to build any new ones. We're going to have to decommission some of the existing ones earlier than planned, and certainly not plan any more ones, which again is going to be very hard if we're going to supply India and Africa with a developed economy.